So, real world exponential models, where they apply, where are they used? When we come back from Christmas break, we're gonna actually have some engineers come in and talk to you guys. They're with the U.S. Army, Navy, U.S. Navy. They're with somebody in the military branch, and they're engineers, and they're gonna come in and kind of talk to you guys about how pre-cal is used and implemented. Why can't I talk, guys? Implemented in their field of study. And how the military will pay for your education. Huh? How about they found me? Yeah, Anna, they hunted me down. Yeah, yes, they did. Yeah, that's theirs. They, I don't know. Focus. Hey, free education. Using math. Here we go. Oh, whatever. Scenarios. We're gonna look at a couple scenarios. We're gonna talk about population growth, radioactivity decay, interest and savings, bacteria growth. All these things are exponential and implied situations. Okay. So first up, we have Surfside High School was built in 2007 and has a growth rate of 1.8% each year. So 1.8% each year. The initial student population was A sub 0 or A naught equals 1,483 students that year. Okay. We're gonna the variable T equals 0 represents 2007 and the rate R written as a decimal. Write an exponential model. Okay. This is our growth rate model. Right here, this guy right here is your beginning bread and butter to write any exponential function. Okay. When you're describing your A sub 0, that's your initial value. Where are you starting? Your R represents your rate and your T represents your time. And most problems will tell you, if it's not in years, it'll tell you T in weeks or T in months. Okay. If it doesn't tell you, then it's implied that T represents years. Okay. This should tie into a class called physics. Just saying. But anyways, I digress. Here we go. So writing our equation. Pretty easy. We read the problem. Now we're going to mark the text. So this value right here represents our initial, right? Here is our rate. In terms of a decimal, what would my rate look like? 0.018. Okay. Yeah. So now I'm going to write the equation. So the exponential model that represents would be A of T equals your initial is your A sub 0, which is 1,483. Parentheses 1 plus your rate in decimals, 0.01. That's, I said 0.1 and I wrote 8.1. That's a skill right there that you guys are just jealous to have. That's not a T, that's a plus.
I thought it was a T writing this down. I think I said I had to.
I feel like y'all are just bullying me right now. All right. Okay. And all you're going to do is clean this up a little bit. And the only thing I need to do is combine like terms. What are my like terms? The 1 and the 18,000ths, which makes this 1 and 18,000ths to the T. Now, was that terrible? Really, guys? No. It was not. Okay, so using your handy dandy formula that you just created, your model for the situation, can you tell me what the predicted population should be in 2024? Yeah. Go for it. Do it. Let me see your skills. Remember, it starts in 2007. Yes, in years. Unless it says otherwise, T is years. 2008. What?
17. For the team.
They clearly weren't doing the problem. I said they weren't doing the problem. Everyone was confused at you. They're like, what? What are you doing? Yes.
Yeah, I was right on the 8.
She just didn't use her unit. I was like, she didn't use her units. She didn't put her title on it, so she threw you off. All right. So the first thing you're gonna do, let's see what do I need to figure out first?
How many years?
There we go. We got to find our year. So we have 2024 minus 2007. That means we're looking for A of what? A of 17. When I know a variable, what do? You plug it in. Oh my gosh, that was so horrible. So approximately, I'm gonna use an approximate symbol. How many students would be enrolled at the school in 2024? 2008 students. And 2024 is the predicted population. Okay. How do we feel about using the population growth model? Doable? We are comfortable with the population growth model.
Yes.
All right, moving on to another example. We're going to talk about doubling. Okay. So what if the size of a population at time t with the initial size p of 0 is a doubling time of k is given by, so this is our doubling model. So notice we don't have a rate because it's telling us what's happening, right? It's doubling. So we're going to be using this formula. All right, a certain fish species was introduced into a tidal basin, 10 months ago. The current fish population is estimated to be 220 and is doubling every 5 months. Okay, find the initial size of the fish population. So what we're going to do is we're going to establish what everything is and what our variables are. So starting off with our P. Our P sub 0 or our P naught equals 220. Agreed? Yes?
That's not the P number. It's asking us
I lied to you. Our P of T. I wrote, you saw nothing. You did as you're due now. Oh, yeah, you're due now. Remember I said your 9 and 10 from your notes yesterday was going to be your due now for today. Huh? All right, sorry. So it's telling you that your ending result, your P of T is going to be equal to 20. It's asking you, what is your P of 0? What did the initial population have to be in order for this to be true? Okay. When we're reading this problem, we can see that our time is given in months. Yeah, I'm going to write it. I was just saying what P of T is, like this is what we're equaling. Okay. All right, in months. How did we get to 220? Well, 220 took place over a period of 10 months. Does that make sense? Our K is how long it takes us to double. How long does it take us to double? 5. So our doubling time is 5 months. Okay, so now I'm going to plug in and solve. So we know that 220 equals P naught times 2. Our time to get 220 was 10, and our doubling value is 5. What do I need to do? 10 divided by 5 is 2. So now we're working with 220 equals P naught 2 to the 2. I'm going to do what? Perfect. I'm going to divide both sides by 4. And so our initial fish population had to be 55. 55 fish. Okay, so it wants us to know, now that we have our initial, we now can write our actual equation. So for any situation, P of T equals 55 times 2 to the 10, the T divided by 5, right? Am I now set up to make any prediction?
Yes.
Yes, it says here, estimate the population of the fish 1 year after they are introduced into the tidal basin. So we're talking about year, but our problem is given months initially. There we go. So our 1 year means that our T equals 12. So we're looking for P of 12, which is 55 times 2 to the 12 divided by 5. So approximately, after a year, how many fish should we have? 290 fish. Yes.
What do you have numbers that big?
To my knowledge, they're not giving them to you. For your test, if you make a note card and you put them on there yourself, then you'll have it. But if you don't put it on your note card, huh? This is the last part. This is the last of this unit. Yeah. Your final, you actually get 1 front page. You're allowed to use 1 front page. Huh? You only get 1 front page. I don't know how you use it. I don't know how you're gonna do. You only get 1 front. All right. All right, our next model we have here is a decay model, a radioactive decay model, okay? And it says, suppose the half-life of a certain radioactive substance is 40 days. And there, huh? Oh. Don't we have 10 minutes still? Oh. And there are 8 grams present initially. Find the time when there will be 1 gram of substance remaining, okay? So we're gonna identify from our story what we know.
Are we assuming that it's like 1 gram every 40 days? Or is it?
That's its half-life. That's when it's cutting. Its K value is the 40 days.
It says 0 after 40 days.
No,
What is?
it's cutting in half. Every 40 days, it loses half of what it's had. It's the opposite of, no, every 5 months, the fish double. This time, every 40 days, you're losing half of your grams. Okay, so we're gonna label what we know. We know our A sub 0 for this problem is what? 8. That's the present initially, right? So we know 8 grams is our initial. Our K, what is our decay value? It's gonna be 40 days. How long does it take? It's taking us 40 days. Because our K is in days, that means our time also has to be in days, okay? Our K is in days, so our time has to be in days. All right, and then now we are looking for our decay. What is our R? It'll be 0.5. Why is it 0.5? Half. R equals 0.5. But anyone know what kind of 0.5?
Negative.
It's negative. Why is it negative? It's decaying, it's losing it, right? I'm not gaining, I am decaying. So R is negative 1/2 or negative 0.5. Does that make sense? Because you are what? Decaying. All right. Can I now, do I have enough to write a situation, an equation, a model? Here we go. So, guys, there's a lot of excess. A of T equals 8, 1 minus 0.5 T over 40. So A of T for this problem equals 8 times 0.5 T over 40.
So every time we do like a half of equation, the rate is gonna be 0.5.
Yes. It is. Look at that connection you made on your own. 1 minus 0.5 is 0.5.
Oh, I'm so stupid.
You just had a little brain fart. You had a little brain fart. No, you just had a little brain fart. Okay, so it's asking us to find the time where there'll be 1 gram of substance remaining. So it's asking us, when is A of t equal to 1? Okay, so we want to know, when is this? So our job here is to get t by itself. So I need to get t, this guy right here, alone. What is the first thing I need to do to get t by itself? Not times 8. Inverse operation. So the first thing I need to do is divide the 8. So now we're left with 1/8 equals.
25.
There we go. Okay, now I need to get rid of the exponent. So I need to somehow get this free. Any guesses on how to get it free? It is. Okay, so going back to algebra 2, we talked about if I need a free, I know, algebra 2. If I need to free a power, I would take the log of the side, right? Based on that knowledge, if you didn't remember that, then your only other option would be to, anyone want to take a stab at it?
What?
You want to take a stab at what your other option would be? No, you cannot take the root. What do you mean? Like,
Why can't you put both sides to the t root and then cancel one out and then, or wait.
because you're just going to be tying the knot even tighter. Okay, the only thing you can do is, if you remember, it is to take the log of both sides. I would take the log of 1/8, the log of the other side, and that frees my power, correct? Vaguely remember doing that? And algebra dose? It's a long time ago. The other thing is, this would probably be a calculator problem, okay? With this being a calculator problem, this means that you're allowed to look for an intersection. Okay, does that ring a bell?
Or you can pull the,
Or you can pull up a table, but a table, if it's not an exact value, will the table tell you that? Okay, so we're gonna model it as if we forgot how to do a log, but we have access to a calculator. Is that cool? All right, so, oh man, how do I solve this? Oh, I know, my calculator. So in your calculator, what are you doing? Yes, that is.
no, my God.
So what you're doing is you're gonna have to plug one side in for your solution is usually your y2, and your equation is gonna be your y1. And what you're gonna look for is their intersection. So I'm gonna pull out good old Sylvie.
Like, since last year, like, you did not know your. Yeah, what? Yeah, what? It's always been Sylvie. Really? I don't know, this year.
Her name's been Sylvie. It's just spelled appropriate. Her name is C. Silver. I don't know. I feel like I've called her Sylvie for a while now. So it's my girl Sylvie. All right, so I'm going to plug in half to the x divided by 40. That's my y1. And what am I searching for? 1/8. Okay. So now I've put those together. I have those values in. I know that these numbers are going to get really large, so I'm going to go ahead and change my window setting. I personally hate zooming, guys. I'm not going to lie to you. I am not a zoomer. I am not going to spend my time zooming in and out of things. It irks my soul. And so I just go in and change my window to make logical sense of it and hope for the best. There's no reason or rhyme to what I'm doing. Thank you for the update. This is our last problem, so we're stopping at today. So good job. All right, I'm going to go to graph. Let's see if my numbers worked. I think I zoomed too far.
Great.
Just a smidge too far out. I overshot it. Just a smidge. I'm going to reset that calculator for me.
That's why.
There's something happening there. Oh. Not enough. Not enough. Let's try that again. Okay, my Y values are real tiny, so we're just gonna,
Why did you break me up for that shit? I had 7 more minutes.
I'm not a quitter. They're gonna touch each other somewhere in here. Oh, they look like they touch. Let's test it out. So we press second, trace, intersect. You want this graph? Yeah. You want that graph? Yeah. You want a solution? Yeah. Bam. And where do they intersect at? It says x equals 120. So it's gonna take when t equals 120, and this is in terms of what? Our time is in days. 120 days for me to be left with 1 gram. All right. So that is our stopping point for the day. Thank you guys for being awesome per usual. Oh, I'll go back to it.
No, I do. But hear you. This is where do you have